Hello and welcome back. Lambda School Data Science, making data-backed assertions. In the pre-watch video with slides and philosophical commentary, we talked about some examples of confounding variables, right? This hypothetical drug study where perhaps gender is related to both the likelihood of taking the drug, purchasing the drug, and the likelihood of getting better from whatever the condition the drug is supposed to treat. And that's a nice story. Let's use Python to actually sort of simulate data like this. And as you recall from the intro course, there's this standard library module called random. So let's remind ourselves, what is in random? All sorts of things, right? So we can import it and we can look at what's inside it. And in particular, there's things like random and randint and randrange, and these are useful for generating random numbers, right? So we're going to simulate some data. Let's think of another scenario. We work for a company that sells accessories for mobile phones, and they have an e-commerce site, right? And the hypothesis is that users who are on the site longer are more likely to buy stuff. That seems reasonable. Right? You know, the longer somebody browses around on your site, the more likely they are to eventually decide to add something to the cart, check out, buy it. But turns out there's another situation, another variable, a confounding variable, if you just want to look at those two, the relationship between time on site and purchase or conversion. And that is, okay, the site actually sells stuff for mobile phones, accessories for mobile phones, cases, what have you. So if you're on a phone, well, you're more likely to spend less time on the site. You know, phones, they do keep getting bigger, but you're still out and about. It's not a desktop or laptop, so you're not spending as much time interacting with the site. But you're more likely to be interested in the actual products, right? You're on a phone. You might actually want to buy a phone case. You clearly have a phone, and you're interested in using it. So, we're going to check out another sort of nice thing from the Python standard library to help us simulate this data. The collections library has all sorts of things, amongst them named tuples. And named tuples behave like tuples, but have names for the fields. And you can make them by giving a name, user for the site, and then an iterable of what the fields are, whether or not they made a purchase, how long they spent on the site, in seconds, say, and whether or not they're a mobile device. So these two are Booleans. And we're just asserting that in a comment. We're not writing code to really test it, but you could think of this as a very lightweight class if you're familiar with classes from more opinionated object-oriented languages. Python, of course, does support proper classes, but it's nice to be able to do this in one line. So, all right, yeah, we made this user class and we made an example user who spent 12 seconds on the site, was not on a mobile phone, and did not buy anything. And when we look at that user's object, yeah, great. Let's generate 1,000 example users. And let's say 750 of them are mobile and 250 of them are not, desktop users. A desktop user has a base conversion likelihood of 10%. And then every 15 seconds they're on the site, it goes up by 1%. They spend anywhere from 10 seconds to 10 minutes on the site, and for convenience, it'll be a uniform random number in that interval. Mobile users, on average, spend half as much time on the site, but they have twice as high of a base likelihood, 20% instead of 10. All right, how do we do this? Well, we're going to make our list of users, and then we're going to loop 250 times, and again, this is just our way of saying we don't actually care about the indicator in the loop. We draw for desktop users, because we're in the 250. Okay, they're on the site anywhere from 10 to 600 seconds. And then whether or not they purchased, well, we can just draw a random number. And this, by default, gives us something in the unit interval from 0 to 1. So it's a probability, really. And we're asking, is that less than 0.1, the base likelihood of conversion, plus time on site divided by 1500, integer division? What's going on here? Think about it for a second. Well, 15 seconds per 1%, but we're in the unit interval, so 1% should really be represented as 0.01. So that's why this is 1500. And we're truncating down. That's what we decided to do. Every 15 seconds, it ticks up by 0.01, the likelihood of them buying. And then we say, okay, did they purchase? How long were they on the site? And false, right? The third thing is mobile. These are desktop users, so that's always false. All right, now mobile, 750, because there's more of them. 5 to 300 instead of 10 to 600 for how long they are on the site. And a slightly different formula here. Time on site behaves the same way. It's just going to be smaller. But the baseline is 0.2. Great. And then, just for good sake, I'm shuffling the users because, we don't want to say, okay, 250 desktop users show up first. And let's look at the first 10 users we get. And yeah, there we go. Okay, a bunch of user objects. So it's a Python list, and here's a user who bought it after spending about a minute on the site on their phone. Great. Here's a user who didn't buy it, even though they spent about 5 minutes on the site, and they were on a desktop. And we can go out here and more and more and more. And if we run this again, we're going to get different stuff, right? Because we chose not to set a seed. But pretty sure the probabilities will illustrate what we want anyway. Now, this is ugly to look at. I did it with pretty much pure Python just because I wanted to show named tuples and remind you about lists. But hey, it turns out if you have a list of named tuples, you can just pass that in to pandas and get a data frame. How about that? So, of course, we ran it again, so these numbers are different from that first run I described, but you can see this 157 corresponds to here. So our first 5 rows, we have 4 people who didn't purchase, 1 person who did. And here's how long they spent on the site, and here's whether or not they were on a mobile device. All right, let's use crosstab, a cross-tabulation, and try to see what's going on. And a cross-tabulation is a special sort of table where you put 2 variables and you sort of see how they slice each other and interact. So we want to do a cross-tabulation of whether or not they purchased with how long they spent on the site. And if you used Excel or similar, you've probably generated crosstabs and maybe even more complicated crosstabs and the sorts of tables that you can generate, pivot tables, which allow you to vary these dimensions. Okay, well this doesn't seem that useful. What's going on here? Time is continuous. Oh, remember, talking about continuous versus discrete. Well, and so time is pretty much unique, and so it just goes off to the right, and Pandas tries to spare us from going off too far. It puts a ... in there, but it's still not useful, because each one of these is unique, so either they bought it or they didn't. It's a 2 by 1000 crosstab. We want discrete buckets, so remember I mentioned binning earlier in the week. This is the time for that. We are going to use pandas.cut and change the user data into 5, the time on site in the user data into 5 equal size bins. And if we use those time bins in the crosstab, we get into a much better situation where it's like, okay, so any time from about 4 seconds to about 2 minutes, 2 minutes to 4 minutes, 4 minutes to etc., right? And okay, that seems right. And it's about 2 minutes per bin, which makes sense because it's about 10 minutes of possible time they can spend on the site. And we drew the numbers uniformly even. And then, okay, did people in this bin buy it or not? Sorry, buy or not? Buying here is at the bottom, true. Now we could look at these numbers and already figure things out. But if you tell it to normalize, that will give you percentages. Or technically, some people think these aren't percentages. I call these percentages. I am used to percentages being in the unit interval, and I suggest you do the same because it's just far more convenient, and scientists tend to talk about things this way. When you're actually preparing a business report for a manager, you might need to multiply these by 100 and add a little percentage sign at the end. And you should probably round them too. And that's okay. But these are percentages. So we're saying, okay, in this lowest time bin, 16% of people bought and 84 didn't. And in the highest time bin, 7% of people bought and 93% didn't. Well, wait a second, right? I mean, we know what's going on. We made the data. But imagine you were just thrown in and given these 2 variables about behavior on an e-commerce site, and you did this crosstab, and you'd be like, wait a second. My hypothesis was the more time you spend on the site, the more likely you are to buy stuff. And okay, maybe that's happening a little bit, right? Going from this bin to this bin, it actually does go up. But then this bin is almost identical to this bin, right? Even though people are spending significantly longer in this situation. And then these bins are just way tiny. And that's an artifact of how we made the data. There aren't any mobile users up here because mobile users don't spend 10 minutes looking at the same site. So we know why. We know there's a confounding variable, and it's called whether or not they're on a mobile device. If we do a crosstab of whether or not they purchased here versus whether or not they're on mobile, we can see, okay, yeah, people on mobile are about twice as likely to purchase as people who aren't. Yeah, that makes sense, right? Like 19% of them are buying versus about 8.5%. And again, we threw in normalize so we could see that with percentages. So yeah, mobile users are more likely to buy things. Now we're still not seeing the whole story here. We'd have to combine all three. And as a live coding during our lecture and or a stretch goal, if you want to investigate it some yourself now, how can we do that? Dig into documentation, think about it, and see if you can come up with a good way to represent the full intuition of what's going on here. I mean, we know it because we generated the data, but pretend we didn't. Pretend we just need to make sense of it. How would you explain and show this to the owner of the e-commerce site and say, hey, here's what's going on here, so you can better optimize your site? And I encourage you to spend some time with that and come to the lecture with questions, and we will go through it together. And then you will also get on to your assignment for the day. So thank you, and look forward to seeing you in lecture soon.